Dobro, dobro. Biće na engleskom, inače.
Dobro. Evo, slobodno kreni kad si spreman.
Super, hvala. Okay, so good morning, everyone. I hope you're seated comfortably at home. Please make sure at all times that you're at least 1 meter away from the screen, because I'll be a meter away from the screen as well, which constitutes the 2 meters, so we don't get infected. This session will be about file tables. I'll show you what they are and how to use them. I'll start with a warning. This is a 90-minute session, which I have to do in 45 minutes. So immediately I'll have to tell you that half of this session has now become your homework. All right, so a little bit about me. My name is Matija. I'm a lawyer formally, but I've worked in IT for over 18 years now. I do specialize in legal information management and natural language processing, but I work with all of the fun parts of SQL Server, which is everything except reporting services and data visualization. I'm based in Ljubljana in Slovenia, and of course you can contact me via the provided contact information if you have any other questions about SQL Server or specifically about the subject, which I'll be covering in this session. So in this session, I'm going to introduce SQL Server 2012 file tables, and then I'm going to show you one of 2 scenarios available as part of this session of how to migrate your database to use a file table to store large objects. Okay, so this introduction to file tables will be brief. I'll try to focus on the second part, the demonstration that will allow you to understand how all of this works. All right, if at any point you have any questions, just write them down, okay? So we can discuss them in the end, all right? Okay, so how to store large object data in SQL Server. In SQL Server 2008, a feature was introduced named Filestream that allowed you to place large object data in a database, in a column, which would normally be a var binary max column. And this column would then physically be hosted on a dedicated database file group. So this allowed you to store large objects in a table inside the database to be covered by all of the transactional and security capabilities of SQL Server, but also allow you to access the file directly. I'll mention that briefly in a couple of minutes. In SQL Server 2012, this Filestream feature was extended to also allow you to expose the data in a database table, in a special database table, so not just a single column, but an entire table, in such a way that this data could become available or accessible through the file system. So if you placed files into this table inside the database engine would then expose them directly into the file system. So this is this special file table, and this is the central subject of this particular session. Now, even earlier in SQL Server 2008 release 2, you know how Microsoft says no new features in service releases? Well, to be frank, this wasn't a proper service release. This was a new release of the same SQL Server, but it also came with another way to store large objects hosted in SQL Server in this remote blob storage, which is a standalone feature. And it's mostly used with large SharePoint installations. So this remote blob storage is actually Filestream, this column level Filestream, that is not hosted on the same, that doesn't have to be hosted on the same physical server where the SQL Server is hosted, but can be hosted elsewhere. And these are the three flavors that are available in SQL Server right now to host large objects in the most efficient way inside the database. So about the file table. This file table is a table. It's hosted on the file stream and it's exposed to the file system. So this is not a folder in the file system that is presented by the database engine as a table. It's vice versa. It's a table that's exposed as a folder. It allows you to store files and folders where you can customize structure, although there are several limitations, which I'll also talk about in a minute. It allows you to store the data inside the database and with all of the large objects hosted on the Filestream file group, which makes it a part of the database, which means it's covered by all of the security and transaction processing capabilities of a database. But those are still files. And in this file table, every file is then exposed to the file system, so it can be accessed directly. So compared to the file stream, where the only way for the client application to access the file is to ask the database engine first for a file handle, and then the database engine allows the client application to access the file. With the file table, the client application can access the file without first asking the database engine for this file handle. So all of the data in this table is exposed directly in the file system and can be accessed without accessing the database engine. The only thing you have to have is the SQL Server instance online. So logically, this data is presented as a table, which means you can access it by using Transact-SQL. But all of the files are also accessible directly in this special folder in the file system. And we've come to the first item on your homework list. This table has a fixed schema, and by following this link, I'll provide the session materials later for you. By following this link, you can access the schema of this table. Because this schema is fixed, there are also some limitations that you need to be aware of, which I'll also discuss briefly later on. So to compare Filestream with the file table, so if you're already familiar with Filestream, then it shouldn't be too difficult to learn about the file table on top of that. So as far as maintenance, consumption, and the security of data are concerned, there are no differences between Filestream and file table. As long as you're using Transact-SQL, you're accessing the data, whether it's hosted on Filestream or in the file table, in the same way. Direct access is available with the file table, so you can access the files directly from the file system when they're hosted in a file table. But before you can stream a file from the disk into the client application on the Filestream, you have to ask the database engine for the file handle, and then you can access the file directly. If you want to organize files, that's natively provided in the file table, but not provided in Filestream. Operating system integration, of course, isn't available for the Filestream because the data is still only available inside the database and only through the database engine. But with the file table, the data is completely integrated with the operating system. Relational access and non-relational access is available for the file table, so you can access the files in the file system or through Transact-SQL. But with Filestream, you can only access the files through Transact-SQL. And if you need direct access, again, you need the file handle from the database engine. So the main benefit of using the Filestream or the file table compared to the regular ways of storing files inside a database column, in a regular database column, is when you're loading data from a regular column that's not hosted on Filestream, all the data needs to pass through the database engine before it can be returned to the client application. But with Filestream or the file table, the client can either ask the database engine for the file handle and then access the file directly, or just go through the file table and access the file directly in the file system. As far as table partitioning is concerned, in 2012, Filetable, it was impossible to partition the data in a file table, but you can partition the data in a file stream. And this hasn't changed in the 8 years since the feature was introduced. So file tables still cannot be partitioned. So these are the differences between Filestream and Filetable. As you can see, the Filetable system is simplifies access mostly to the files. To implement the Filetable, you need to do this on 3 different levels. First of all, you need to enable the file stream at the instance level, which you can do this with the system procedure sp-configure. And you need to enable both access levels through Transact-SQL and through the Win32 access level, which actually exposes the data in the table into the file system. And then at database level, you also need to create a Filestream file group. And this Filestream file group will be used to host the data physically. Then again, at database level, you need to enable non-transactional access to the database, which will then allow the files to be accessed through the file system. There are, of course, 3 levels. The non-transacted access can either be turned off, which means that the files aren't accessible, they're not exposed, that the feature is turned off, or the files are available for reading only with a read-only setting. And of course, the full non-transacted access allows you to allows your users also to edit the files, not just read them, or make changes to the file table. And of course, you need to make sure that the database has its own root folder. This root folder needs to be created. Its name must be unique across the entire SQL Server instance. So for each database, you can only have one root folder. And for the entire instance, you have a single root folder as well that also exposes Filestream data. Okay, and I'll show you all of these when I do the demo, so it's easier to understand. So there are many things you have to do before the feature can be turned on, but nothing too difficult to implement. As far as the database root folder is concerned, there can only be one per database. This root folder will then allow access to all of the file table folders. So for each of the file tables that you create inside this database, their folders will be accessible through this database root folder. The database root folder is, of course, completely integrated with the database engine. You can only manage it through data definition language statements. And of course, when you drop the database, the root folder and all of its contents are automatically removed as well. Because it's completely integrated, it's also fully integrated with the backup and the always on features. So again, the data in file tables exists inside the database, and it's only exposed to the file system as files. So the files are physically and logically part of the database, not the other way around. Okay, and now we have 4 slides of limitations that aren't important right now because we don't have enough time to go through all of them. So these have now also become your homework. So because the for instance, the schema of the file table is fixed. You cannot change the layout of the table. And of course, there's no such thing as a temporary file table. After you've created the file table, you can no longer change so many of the things that make it, but you can add constraints if needed. Although, because again, the schema is fixed, you cannot add columns. And of course, before you remove the file table, you need to make sure that none of the files are being used. And of course, there are some additional limitations which we don't have time to go through. I'll just point out the most crucial ones. For instance, the file system structure inside the file table must not exceed 15 levels. So when you're 15 folders deep, you cannot create any more folders. This limitations comes from the way the hierarchy is implemented between the files and the folders inside the file table. There also, the behavior is also different for snapshot isolation and recommitted snapshot isolation, which means that the database engine automatically detects if a file has been changed outside of a transaction. So if two users are accessing the same file, one through the file system and one through Transact-SQL, the way this is implemented does not guarantee that they will be looking at the same file, right? Because if the file is changed to the file system, it's changed outside the transaction. So this is something you need to consider when planning. And of course, if you're using Notepad and Paint, you will no longer be capable of opening these files in these two editors because they're using memory mapping. So they don't load all of the files into memory if memory is scarce, but they do this low-level approach to accessing file data, which is no longer supported when these files are placed in a file table. And the rest of the limitations, of course, we don't have time for. So I'm now going to demonstrate how to migrate an existing database to use a file table. I've prepared two scenarios in this session, but unfortunately we only have time for one. So I'll do scenario one with the distributed maintenance, and then scenario two will be available for you to do on your own time with the distributed consumption data model. So a little bit of background for this scenario. So we're looking at a document management system application where documents are placed in files, are represented by files. We have two different environments, one for maintenance, which is named the OLTP part. So in this maintenance environment, the editors need full access to the files. But then once the files have been completed, once every of the file has reached its final version, this file can then be published to the consumption environment, to the data warehouse part. And in this consumption environment, the files are read-only and available to the subscribers of the system. So editors can only maintain the files in the first environment, and the end users can only access the files in the second environment. As far as maintenance is concerned, there are two objectives that this application or this system must comply with. The first, we want full transactional document management. So regardless of whether changes are made to the file or to the metadata that's stored in the database, we want all of the changes to be transactionally safe. And of course, we need to provide a complete overview of all of the documents and all of their attributes. Some of the metadata is represented in the database and is edited by the editors, but some of the metadata are actually file properties, and these are maintained automatically by the operating system where the files are hosted. So there are two different worlds that need to combine inside this database. As far as consumption is concerned, the documents must be made available through the web, hosted through an ASP.NET application hosted in Internet Information in an Internet Information Server instance. And of course, the end users need read-only access to the files. So graphically, this means that we have a database and a file system. So even in the OLTP system, we had a distributed database, this distributed storage. So inside the database, we have the document metadata. Any changes to the document metadata are managed by the transaction processing capabilities of SQL Server. And any changes to the file are done outside of this database. And the situation, of course, is the same in the data warehouse. The document metadata is hosted inside the database, but the files are hosted in the file system. There are 4 drawbacks to this situation. Number 1, if you want to maintain transactions correctly, you have to create your own transaction management inside your application, inside the client application, that maintains changes to the file in sync with the changes to the metadata. Because the files are kept outside of SQL Server transaction processing capabilities are not available for the files. Second drawback, we're using a distributed storage system, and we're now using 2 different security models. So the database security model inside SQL Server and the file system security model, they need to be aligned. For instance, when editors make changes to the metadata, these same editors must also be allowed to make changes to the file, right? Otherwise, the file and the metadata can get out of sync. The third drawback, we have 2 different backup strategies, which also need to be aligned somehow. The SQL Server backup strategy is simple on its own. The file system backup strategy is simple on its own, but together, I can only say good luck with this, because it's difficult to align them correctly. And of course, the fourth drawback, maybe the only one really visible through this diagram, is the fact that there is no referential integrity between the metadata in the database and the files in the file system. So your client application also needs to make sure that no orphans are created on either side. So if a file is removed, its corresponding metadata should be removed as well. And of course, if the metadata is removed, then the file should be removed as well. So there are 4 things that your client application needs to do in this case that aren't as easy to do compared to if all of the data was hosted in the same system, for instance, inside the database. But there are 2 benefits of this situation. One is the transfer of data from the OLTP system to the data warehouse system is easy. So for the metadata, that's just a simple ETL. It moves the data from the OLTP system to the data warehouse table. And for instance, for the files, it's just simple file copy operation. Could you mute your microphone, please, whoever it is? All right. So to recapitulate the scenario 1 details, So we have in both environments, we have a distributed data store. Files in the file system, metadata in relation to database, the drawbacks, again, transactions need to be maintained by the client application. Referential integrity is not supported. We have two different security models and we have two different backup strategies. But two advantages are direct file access. So either the editors in the OLTP system or the end users in the data warehouse can access the files directly without any problems. And the transfer of data from the OLTP system to the data warehouse is as simple as possible. So the objective of this upgrade with using file tables would be to remove all of the drawbacks, but retain both of the advantages. Okay, so I'm now going to show you how to upgrade your database in the appropriate way. Right. If the virtual machine is, oh, it is still with us. Okay, so I'm just going to quickly show you the contents of this database, but all of the scripts will be available to you, so you will always also be able to experience all of this firsthand. So in this case, if you don't see everything correctly, you don't have to worry because it's not really important right now. So inside this file database, I only have a single table, and this table contains all of the document metadata. Okay, and the files, of course, are hosted in the file system. Here in this file repository, file database 1. So we have some images and some Word documents. That's all. All right, so to upgrade this to use file tables, we first of all need to make sure that all of the instance level and database level settings are correct. So I need to make sure that the Filestream access level settings are turned on. So the configured and running value should be 2. Of course, if this is not turned on, you can turn it on by using the same system procedure. And this running value of 2 means both levels of the access. Transact-SQL, which would be 1, and Windows 32 file system access, which is the number 2. All right, I'll examine the current situation inside this file database. So let's look at all of the space properties of this database. You can see here that there are 2 data files used for data. The primary and the main file, where the main file is the default. And of course, we have a log. So what's missing here is the Filestream file group. And in the bottom, you can see that the non-transacted access has not been turned on for this particular database. So this is what I have to turn on now. First of all, I need to add a Filestream file group. This particular case, this file group needs to expose a logical name that will be used to target when we place data on it. But when you provide a file to this file group, this file is actually just a folder. Okay, this folder will be placed in the file system. And this will then host all of the Filestream data in this database. I'll show you a couple of links in the final slide where you can find additional information about using Filestream, but I'm going to tell you immediately that when you create this folder, you need to make sure that it's completely secure. Only the account used for the database engine should have full access to this folder. If any other accounts have access to this folder, the data in this folder might be corrupted. And when the data here is corrupted, you might lose individual rows inside the tables, or in case of the file table, you might lose the entire file table. So make sure it's secured correctly. Right, so I've run this now and created the new file group. I'll just verify the situation again. So there's a fourth file group added, and this one will host the Filestream data. Okay, just let me quickly check the table properties of the document metadata. So it's a fairly small table, only 167 rows in 6 pages. So not a very large sample. Okay, so I now need to make sure that this database exposes the data to the file system. I need to make sure that I turn on the non-transacted access. The specification said that it needs to be read-only, but the editors will also have to write make changes to these files. So this access should actually be full, but I'm setting it to read-only because I want to show you something later on. So I need to enable the non-transacted access, and I need to provide the folder name that will allow access to this database, to any file table data inside this database. And as you can see here, I should not be doing this while other users are accessing the database, because I have to put the database in not just single user mode, but at least remove all of the connections to the database for the duration of this operation. So make sure that if you're running upgrades like these, that you run them outside of work hours. Otherwise, people will be upset with you. So by altering the database, I'm now creating the folder, and I'm enabling the non-transacted access. So if I look at the database properties now, I can see that this database uses a case-insensitive collation, okay, which is something that I need to know. And if I check the settings for the database again, pay attention to the third table, we can now see that non-transacted access has been turned on, and the directory name is file database 1. So in the file system, I should now already see the root folder of this database. So by connecting to the instance folder, I can see the MS SQL Server folder, and in this instance root folder, I can see the database root folder, which is currently empty because I haven't created any file tables. Okay, so this is the new folder that was created when I ran the script. Okay. Now, regarding the collation, this database uses a case-insensitive collation, which is compatible with the default file system collations, because in the file system, all of the collations usually, everything is case-insensitive. This is important because when you're creating a file table, you need to make sure that the properties of the columns are also case-insensitive, so that they're compatible with the file system. Okay, so this is the first stage of this preparation. Now let's continue with the table. So inside this file database 1, I currently have a single table with all of the document metadata. And the document metadata, of course, contains some of the document properties like the title or the abstract. but the rest of these properties are actually file properties. So currently, if I want to keep them in sync with the situation in the file system, the client application needs to maintain all of these properties as well. One of the properties is the file path pointing to the file. I'm now going to create a file table. In this file table, I need to specify the name of the directory. I'm going to use the same name as the table name, so document.store for the directory. I can name the default constraints provided as part of the fixed schema of this table, if I have a specific naming convention. And in case the database where this table is hosted doesn't use a case-insensitive collation, I can specify which case-insensitive collation to use for this file table. Okay, and this is all I have to set for this file table. And of course, when I select from the file table, it's currently empty. Now, I could use a complicated script to get the data from the files into the table, but I can simply use the direct access. So if I just grab all of the files from the original location, so both of the folders, so select all, copy to the clipboard, and then go into this document store folder, which has now become available, and just paste all of the files in there, I can load the data into the table. However, currently the access to this file table is read-only, so I need to change it to full so that I can actually load the data into the table. So this is what I wanted to demonstrate. Okay. And when I try again, all of the data is loaded into the folder. And the database engine, of course, reads it into the database, into the table. Okay. And if I check the document store table now, it contains all of the data. I can also see which of the items here, which of the rows represent files and which represent folders. Okay. Again, the details of this table schema are part of your homework. We don't have time to go into too many details here, but the data is now loaded inside the database. I need to make sure now that I create referential integrity between the metadata and the file table data. And I first do this by modifying the document metadata so that it corresponds, the file names correspond to the, so that each metadata row now points to a row in the file table. Okay, to simplify things. I'm going to do this by adding another column to the document metadata table. This is going to be a stream ID column of type unique identifier, and it's going to be null in the beginning. Okay. And I need to make sure that the stream ID is populated, and I'm using the file names to create references between the file table, between the file system and the metadata table. Okay, so 167 rows affected. And with this next query, if this next query returns any data, then I have orphans. Nope, it's empty, so no orphans here. And if I examine the table again, this table should now have an additional column in the end. Sorry, not this one. The metadata table. And this stream ID column now points to the corresponding file in the file table. But let's continue with the migration. Now that the stream ID values have been set correctly, I can make sure that the stream ID column is no longer nullable. All right. And I also create a foreign key constraint between the metadata and the file table. All right. So if any files have to be removed, you have to make sure that the metadata is removed in the same transaction. And because this is now enforced by a foreign key constraint, you will not lose any data on either side. I also make sure that the stream ID column in the metadata table is unique, because this is how file systems work, right? Every file can only be placed once in the same folder. And now I can remove all of the columns from the metadata table that are now being maintained automatically by the database engine. So size, document type, file path, created time, modified time, access time, all of these columns can be removed because they're no longer needed in the metadata table. They no longer need to be maintained by the client application. Okay, and if I'm doing this during the night, I can also create a view so that in the morning, when the developers come in and the old metadata table is no longer available, I can replace the old queries that use the document metadata table with this new query that combines the data from the old metadata table with the new file table properties, which are actually file properties and no longer need to be maintained by the client application. So with this quick setup, we have made this important change to this database. So let's look at the tables quickly again. So still only a single table here, because in the Object Explorer, all of the file tables have been placed in a special folder. So this document store file table contains all of the files. Okay, this is as far as this scenario 1 is concerned. In the end, we now have no longer a distributed system, but the system behaves as if it were distributed. So all of the data in both environments, OLTP and data warehouse, is hosted inside the database. We're using a single security model. We're using a single backup strategy. And of course, transactions are completely safe because they're maintained inside the SQL Server database and no longer need to be maintained by the client application. Both the metadata as well as the contents are now hosted inside the database in both environments, but they are also exposed through the file system, so they still can be used directly either by the editors or by the end users. So we've made sure that we retained both of the benefits of using this approach from before. So direct file access and a simple transfer from OLTP to data warehouse are still here, but we've also made sure that the transactional safety is available. We're using a single security model and a single backup strategy. And of course, after you finish scenario 2, you will also have this objective met. Okay, there are a couple of warnings when using file tables, full text search, and statistical semantic search. We don't have time to go into too many details here. There's also a bug that was fixed with a hotfix later on. And of course, you need to do further reading in order to understand everything that you have to before you can use all of these features in real life. So I'm going to make sure that all of the data becomes available to you. And everything you need to know is available in this Migrating Blobs to File Tables article that I've written 8 years ago for the MVP Award program. And it's still available on the msdn.com blogs. Okay, so if you have any questions, we've unfortunately run out of time, but please send them over through email or contact me through Twitter and I'll see if I can answer them. All right. So thank you very much for being here.